Hello students, welcome back to my channel. Let us continue learning database concepts. In previous session, we had started relational algebra and we had covered all the mathematical operations related to the relational algebra. In today's session, we will be covering the database operations. Okay, so let us start. So when it comes to the relational algebra, and under that database operations, the very first thing we are going to be learning is relational select. Okay, so what is this select? Select is used to obtain a subset of tuple of a relation that satisfy a select condition, right? So now in future coming sessions, we will be learning many things about SQL. So for that, this will be a foundation for you. Okay. So when I say select, a subset of a tuple is selected. What is the meaning of that? Suppose I have a student database, right? Okay. So this is a relation I'm having of student. Remember, a table is called as a relation when it comes to relational algebra. So I have many number of students here. Students data I have. Each row represents a student. So when I perform a select operations on this particular relation, I'm going to be selecting a subset of tuple based on certain condition. Okay, so what is that? For example, I might be wanting to select a list of the student who are studying in second PUC only, okay, from an organization who have taken PCMC as their subject. So at that time, I will apply this select with this condition, and only those, for example, if these are the two, only these students have taken, so only their data will be retrieved from the database. So this is nothing but I had n number of tuples here. I'm only selecting a subset. That is why we will say that it will select a subset. Okay, so that this is your relational select. So there is an example given here. Find all the employees born after 14th Feb 2014. So how am I going to write this? Okay, so this is the way I will write. I will write the keyword select. So date of birth is equals to 14th Feb 2014 of employee. Now what is this inside the bracket we have? This is nothing but our relation. Okay, so I am applying this select operation on relation, and this is my condition. So whoever, if at all there is any employee who is born on this particular day, then his name will be, that entire tuple will be displayed in the output screen. Okay, which means we are retrieving that data from the database. That is your select operation. Remember, select operation always selects the subset of a tuple, right? So let us move on to the next operation. Relational project. Now, what is this relational project operation? Now, project operation is used to select a subset of attributes. Okay. So what do you mean by subset of an attribute? Let us take the same example. I have a student. Okay. Student detail I have. This is a student relation. Now, when I say subset of attribute, what all attributes can a student have? It may be register number. It may be his name. It may be his mobile number, marks, okay, course he has offered. So depending on organization to organization, we might be having n number of attributes for a particular given entity. Okay, so in this relation, I have these many attributes. So a student's register number, name, mobile, mark, and course I have. So when I apply a project operation on any relation, what is going to happen is I'm going to be selecting a subset of the attribute, which means, for example, if I'm saying that project the register number and name of the student only, which means I will get the details of all the students, but only column wise, which means I'll be getting the subset of the attributes. Okay, so this is a difference. Select is a subset of tuples, and project is a subset of columns or your attributes, right? So an example is given here. For example, to get a list of all the employee surnames and employee numbers. Okay, so what do we do that time? So we want all the employees, remember. So when it is all the employees, but we are asking for only certain attributes, so then I will use project operation. So in project, surname, employee number, or from the relation employee. So this is the relation or a table on which I'm applying the project operation. So I'm going to get only those two columns, but it will include all the details of the employee. Okay. So this is how relational project and relational select work. So if I had to see how it is combined together, okay. So of course, in a database, when I want to retrieve, I do not want the entire, either I do not want the entire tuple to be retrieved, or I do not want all the students' detail to be retrieved. Okay, for example, I want a student detail who is studying in second PUC, okay, and only whose name is certain name. So that time, I want only that particular name column. Also, I want only that particular student, isn't it? So there is a restriction on the column as well as there is a restriction on the row as well. So how do I do that? That time I will apply the selection and project operations together. So we have this option of combining them together. Okay. So select and project can be combined together. For example, to get a list of employee numbers from employee in department number 1. So let us see how we can do that. As you can see here, project employee number, that is, suppose this is my employee table. I have employee number. Okay, so I am taking only this employee number column, restriction on the column I'm putting. And then I'm saying from that column, select department number 1 only. Now I'm putting restriction on the department number also. So there will be department number, isn't it? So department number, whichever is matching with 1. For example, if this is 1, which means I want only employee number. Okay, this column, under that I want only department number 1, which is this one. So only this particular cell will be selected. I hope this is clear. Okay, so that's why project employee number, we are putting restriction on the attribute. Then I'm saying that from there I want department number. This can also be written in other way also. Select department number is equals to 1. Okay, project employee number from a relation. This is also fine. Right? Okay. So see this is how we write in SQL. So SQL we will be learning in detail. So as of now, you need not worry, but a simple example is given. In SQL, we will write it as select employee number. So employee number is nothing but the name of the attribute from employee. Employee is nothing but the table. Okay, so this is the relation, or in case of SQL, we will say it is a table where department number is equal to 1. Where department number is equal to 1 is nothing but I am putting a select operation. Okay, that condition saying that department number should be 1. So this is how we will write in SQL. So SQL we are going to be learning in detail. As of now, you need not worry. Right? So this is how we will do the select and project operation together. Next, we have join operation. So what is this join operation? I hope all of you remember the cross product we have studied in the previous session. Okay, I told you that we'll be using it in the coming session. So this is where we will be using those cross product. So before that, what is join? Join is used to combine related tuples from 2 relations. Okay, so if I have 2 relations, I'm going to be using join to combine them together. Various reasons we might be wanting to combine the 2 relations. Okay, because maybe if it is a student detail, it is available here, and his academic detail is available in another table. Okay, so that time I need to combine them together in order to get the final marks card. Okay, that is the reason. In its simple form, the join operator is the cross product of the 2 relation. Okay, so we will say that join operator. Simple join is nothing but a cross product. What is cross product? Cartesian product we have studied in the previous session. That is nothing but I will take one row and multiply or combine it with each of the row. Similarly, I will take the next row and I will combine it with all the rows of other table. So it is nothing but a cross product. Like that I will do with all the rows. So A join allows you to evaluate the join condition between the attributes of the relations on which the join is undertaken. So we can evaluate the join condition. So when we are joining, there can be a certain condition also. For example, register number should be equal to certain number. Like this, we can also give a join condition. Even that is allowed. You need not join all the values. You can give certain condition. Based on that only, there can be certain join operations performed. That is also fine. Okay. Now the notation what we use is, we will write the relation and we will write the join operation. There has to be, remember, there has to be two relation if you want to perform a join operation. So here the relations are R and S, and join is the, I will use this particular keyword, and this can be join condition. Okay, for example, it can be department number should be equal to the department number. That is, only when you have the same department number, then only we should join those rows. Such conditions you can give. So when we see the examples, it is going to be a more clear to you. So see here. So I have a relation. These are my tuples. Similarly, I have relation S. These are my tuples. Now, see here, R join. The join condition is R dot column A is equal to S dot column A. Now, remember, I'm using this dot operator to tell you that this attribute belongs to R. Okay, which means R dot column A means I'm talking about this particular column. Similarly, S dot column A means I'm talking about this particular column. So only when they are equal, I have to join, right? So usually in Cartesian product, what did we do? I was multiplying with all the rows, isn't it? But here I will join only when it is matching the join condition. So let us see. First, I will take the first tuple A1, A1. Yes, this is matching. So I will keep the entire tuple. So this is A1 of R and this is of A1 of S. Next, do I have B here? B I don't have. So I'm going to cancel it out. Similarly, do I have D here? D, yes, I have D here. D is matching. So D3, D3. I'm going to keep it. Okay, this I'm going to keep it. This I'm going to keep it. What happens to C? C is not there. So again, I'm going to cancel it out. D is there. F is not there. I'm going to cancel it out. We are first checking over here. Okay. Remember, the condition is between these two columns. This should match. If it is matching, then I'm going to keep the entire tuple of both R and B. Sorry, R and S. We are going to keep. Next, E. Do I have E? Yes, I have E here. I have E here. So I'm keeping E5 and E4. Remember, in the last session when we were doing, we were checking the entire things. Okay, both should match. But here we are only comparing the column A of R and column S of R. Sorry, column S, A of S. So that's the reason when there is a match, I'm going to retain it. So this is your R join S for the condition column A is equal to column A of S. Okay, let us see this one. R join R column B is equal to S column B. Now, what is the meaning of that? Now we are comparing the columns of B column. Okay, which means now the comparison should happen here. The moment I find equal, I will keep those entire tuple. So is there 1 and 1 here? Yes. So I'm going to keep. So A1 from R and A1 from S. Do I have 2? Yes, I do have 2. So I'm going to keep B2 and C2. Okay, which is over here. Do I have 3? Yes, I have 3 here as well. So I'm going to keep D3 and D3. Okay, which is over here. Do I have 4? Yes, I have 4 as well. So I'm going to keep F4 as well as E4. F4 and E4. Remember, I'm only bothered about column B is matching or not. I'm not going to see the column A, right? Because my join condition is telling me to only check that. Okay, students, I hope this join is clear. Okay, so whenever we use equality sign, we will call such join as equi-join. Okay, a join involves an equality test and thus is often described as equi-join. So the previous example, whatever we did, we can say that it was an equi-join. Such joins result in two attributes in the resulting relationship having exactly the same value that we have seen. Now, what is a natural join? A natural join will remove the duplicate attributes. Okay, natural join is nothing but just like our Cartesian product, but we will remove the duplicate attributes. In most of the natural join will require the attributes have the same name. Okay, so this we have seen in the last class. This may require a renaming mechanism. So we might have to rename it. We will learn that how to do that. So if you do use natural join, make sure that the relations do not have any two attributes with the same name by accident. Okay. So relationship should not have the same name. Otherwise, there will be a lot of confusion. So natural join. So equijoin is nothing but the example what we saw just now. Okay. So while learning join, we also learned about equijoin. Natural join, you can consider it as same as a cross product, what we have learned in the previous session. In detail, we have learned. So I request you to go through that lesson. Okay. So where we will remove the duplicate elements and we will, if in natural join, what happens is same cross product we will do and we will remove the duplicate elements. That is nothing but our natural join. Next, there are several other types of joins. Now, this is important, you should know. Outer joins. Now, what is this outer join? Why is this outer join? So much of the data is lost when applying the join in two relations, isn't it? So when we were comparing, we know that whenever it is not available, we were not keeping those tuples. So that is a loss of data. Because ultimately what is happening is we are applying everything on a database and database has data which is not unnecessary. There is a reason why we are storing all the data in the database, isn't it? So if at all I'm losing certain data means I'm losing certain information. So in some cases, this lost data might hold useful information. So we do not want that to happen. Okay. So that is the reason outer joins are used. An outer join retains the information that would have been lost from the tables. Okay, replacing the missing data with nulls. So replacing the missing the data with nulls is nothing but it will tell that there was a data. Okay. So we'll know that there is something which we have not been able to enter because of the join conditions. So there are three forms of outer join. Left outer join. So it keeps the data from the left hand table. Okay. Right outer join keeps the data from the right hand table. Full outer join keeps the data from both the tables. Now, we know that there was R and S, isn't it? So if at all, so remember that join operation is always used something like this. So when I say left outer join, we will use this symbolic notation, which means I'm going to keep all the tuples of the left table, okay, irrespective of the fact that whether it is matching the condition or not, right? Similarly, if at all I mention, so when I say this is simple join, this is left outer join, this is right outer join, and this is full outer join. Okay, so these are the symbolic notation you should know. So when I say this, which means that I'm going to retain all the data which is not matching the join condition from the right hand side table. This means that I'm going to retain all the values of the left and right table both, whether they are matching the join condition or not. Okay, so we will see some examples. It will be clear to you. So this is the table which we have already seen, right? This example we have seen. Now, based on this only, we will be doing certain outer join and left and right outer joins. So we have our left outer join, R dot column A is equals to S dot column A. Okay. So here the join condition is once again equality. Okay. I'm saying that column A of R should be equal to the column A of S. But the condition here it is left outer join, which means I'm going to retain the tuples of the table which is on the left hand side, which is R. Okay. So see here what is going to happen. Same thing. I'm going to compare first. A and A matching. Yes, I'm going to keep the tuple of both the tables. B, there is no B. Okay. So I'm leaving it as of now. I will tell you. So this was not there. I'm going to check D. Is it there? Yes, D is there. So I'm going to keep this. So D I have written. F, is it there? F is not there. So let us keep it aside. E, yes, E is present. E is present. So I'm going to write E. Okay, now since this is a left outer join, what are the other tuples which are not there from S? C was not there. So I'm going to ignore this totally. But these two, which is B and F, since it is a left outer join, I'm going to keep them at the end, wherein which the data of the left table will be written as it is and null will be written for the data of the right hand side table. Okay, I hope this is clear. Once again, we will do the right outer join. It will be clear. So see here, right outer join. I'm saying R right outer join, which means the table which is on the right hand side should retain the tuples, right? So once again, the same join condition, that is column A is compared with column A of S. Okay, but here it is right. So right side we have the yes table, right? So let us compare. I have A, yes. I have D, yes. Okay, C is not there. I'm keeping it aside. B is also not there, but I'm going to ignore this as this is not left out to join. F is not there. I'm going to ignore. E, yes, it is there. So I'm going to write E. Now, in this case, we will be totally ignoring all the matching which is not found. But when it comes to the right hand table, I'm going to retain this particular tuple. Okay, so that is why I've written C2, and for the respective left hand side, I'm going to be filling it with null value. Okay, either you can write dash here or you can directly write null. That is also fine. This is your left and right outer join. Now let us see how can we do full outer join. Okay, so what did we say? How does a full outer join work? Full outer join works, that is we are going to retain the values of both left and right hand side table. So I have R full outer join. R column A should be equal to S column A. Once again, the same condition. This should match here. Okay, and it is full outer join. So first let us write whichever is matching. A is matching, B is not there, D is matching, C is not there, F is matching, no, F not there, and E is matching. So we'll write first A, D and E. Okay, A, D, E. So both the values are there. So I'm going to write. Next, I will check in the right hand side, whichever was not available. So this was not available and this was not available. So I'm going to write those value, and for the respective right hand side table, I will fill it up with null. Remember, we will not be directly filling with value. For that particular values, we will be writing null. Next, I will check for the right hand side table, whichever was not available. In this case, C, I will write for the right hand side and then I will fill it with the null value. So this is how the full outer join works. Now by doing this, otherwise if it was a regular join, we would have lost all this data, which might be crucial, isn't it? Our table would have got reduced to only this much. But by doing outer joins, various outer joins, depending on the requirement, we can still keep the data and we can prevent it from data loss, right? So this is about your database operation, students. I hope these videos are helping you all in your studies. So keep watching, keep learning. Thank you for watching.